Imagine waking up tomorrow and the sun just stops, not for a minute, not for an hour, but for a full 24 hours. The burning star at the center of our solar system freezes in place. No light, no warmth, a cosmic pause. For a moment, the world stands still, but soon, chaos unfolds. This isn't science fiction, it's a thought experiment, a journey into what would happen if the sun, the very engine of life, stopped moving for a single day. The sun is a massive, searing sphere of plasma. Every second, it fuses millions of tons of hydrogen into helium, releasing energy that bathes Earth in light and heat. This energy drives weather, fuels photosynthesis, and regulates the delicate balance of our planet's ecosystems. Now, imagine if that process paused. If the sun froze in time, what does that mean? Not exploding, not vanishing, simply stopping. Its radiation output drops, its movement relative to the solar system halts. For 24 hours, the sun's warmth and light stop feeding the Earth. To understand the stakes, consider this. The sun emits roughly 3.8 x 1026 watts of energy every second. That's enough to power the entire planet billions of times over. Without it, the Earth begins cooling almost immediately. Temperatures plummet. The atmosphere, which traps heat through convection and radiation, starts losing energy. Water vapor condenses. Storm systems collapse. Plants, which rely on sunlight for photosynthesis, halt their processes instantly. Oceans, rivers, and lakes don't freeze in seconds, but their surface temperatures start dropping. Gravity, the sun's mass still holds the planets in orbit. But light and radiation? Gone. Historically, Earth has endured periods of darkness. During volcanic winters, ash clouds can block sunlight for months. During ice ages, lower solar output contributed to global cooling, but a sun frozen in place is orders of magnitude more extreme. A volcanic winter dims sunlight by a few percent. A frozen sun? 100% drop for 24 hours. Space missions and satellites rely on solar energy. Overnight, power grids might survive using stored energy, but life on the surface would feel the immediate shock. Even astronomers would notice subtle gravitational anomalies. The planets would continue moving, but the balance of energy in the system would shift. In the first hour, darkness begins. The sun appears dim, frozen like a photograph. Shadows vanish, solar panels fail. People notice an unusual chill, even in the tropics. Birds stop singing, animals become confused. By hours 2 to 4, temperature drops several degrees. Early frost forms in regions unused to cold. Cloud patterns stall, winds weaken, photosynthesis halts. Crops under artificial light keep growing, but nature's systems pause. By hours 5 to 8, oceans begin cooling at the surface. Air currents slow dramatically, jet streams become erratic, humans and animals instinctively conserve energy, electricity usage spikes as lights turn on. From hours 9 to 12, ice begins forming in polar regions at an accelerated rate. Rivers in cold climates partially freeze. Night spreads unnaturally long across the globe, plunging people into a surreal twilight. As hours pass from 13 to 18, the planet's rotation continues, but everywhere is darker, colder. Wildlife struggles to adapt. Predators cannot hunt normally. Migratory patterns are disrupted. By hours 19 to 24, the sun remains frozen. Human panic spreads. Communications rely on backup power. Nature braces silently, but finally the 24 hours end. The sun resumes its motion. Light and warmth flood the planet again. Air currents surge. Plants resume photosynthesis. Oceans slowly regain surface temperatures. The disruption lasts hours, but the psychological shock and ecological ripple effects linger. Life on Earth is fragile. It depends on the precise rhythm of our star. Even a single day without its energy reveals how delicately balanced the planet is. A frozen sun is hypothetical, but it teaches a lesson. The sun isn't just a ball of fire in the sky. It's the heartbeat of life. Without it, we are vulnerable. Without it, the world we know would pause, falter, and fight to recover. The scenario reminds us that cosmic events, whether sudden or gradual, shape our survival. Humanity often assumes permanence, but the universe is anything but permanent. So, what if this wasn't just 24 hours? What if the sun slowed its fusion permanently? What if another star passed close enough to destabilize our solar system? The universe is full of what-ifs, and each one tells a story more terrifying and more fascinating than the last. Stay curious. The next cosmic question might change everything you thought you knew about life on Earth.